this computer. 1 second. I want to pull out. I want to pull out a segment of code to give you an example how I actually. Wait a minute. It doesn't allow me to do this. Okay. Can you see my screen?
No, we can't see anything right now.
Okay, that's great because I don't want to show you everything. That's why I said, make sure that you don't see my screen before I pull out a segment of code and then I can. Okay, give me 1 second. I'm actually trying to extract a chunk of code that I can show it to you. Okay, now I'm going to, I think I'm ready to share the screen. Okay, so now you can see my screen, right? So I just want to show you this piece of code. This is piece of code which is you couldn't find anywhere in the my break, because my break I didn't check anything. But here is how I check the chunk size. So I use three new function call in Unix. So in this code, I actually use 3 function call, which I know you will ask me this question, and this is a moment for me to do a little bit of coaching. I use three system call: fsic, ftl, and the rewind. I use this 3 function call. So they're all system call. By the way, you can do man fsic, ftl is here, rewind, they're all here. If you do man fsic, you should get all 3 function call: fsic, ftl, and rewind. It's essentially let you reposition where you are in terms of reading the file. So you can think about, usually when we open the file, we just open from the beginning and then read through it. So there is a pointer go with it as we read through the file, write through the file. But you can imagine sometimes we want to jump around. We want to do random search. We want to basically jump to a different location. And that's why this function fsic, ftl, and rewind, they're so important. So now let's go back to piece of code, how I did this. It's the first one I did is I do a fseek. So the fseek is essentially I look at to move that pointer all the way to the end. So fseek, the third parameter, say, where do I want my pointer to go all the way to the end? So fseek, by doing this, using the parameter 6_seek underscore end, it will move the pointer immediately to the end of the file. And then after I move to the end of the file, I use ftl. ftl basically give me the position between where I am and the beginning of the file. So ftl is showing the distance, which is essentially if I move to the end, then I will be able to tell how big the file is. So this is essentially trying to help me to determine the file size. Okay, this is a very typical way for us to do that. In the C program, you want to figure out how big a file is. You use fseek, and then you use ftl. So by doing this, the L side, you can see that, be careful, I'm actually declare this as a long. I'm not using int, I'm using long because the file size could be bigger than 32-bit integer. By the way, in C today, most of the integer is 32 bits. But long is 64 bits. So now, because the file size could be big, so I'm using long to make it really big, okay? So you can see that L size is now the file size of the chunk that I just opened it. It's a TF, remember this particular TF. And then what I did is that I checked whether the chunk size is equal to L size. Remember, chunk size I already compute earlier is the argument number 3 or argument number bracket 3, which is the fourth argument, times 1024. And I want to see that if that number is equal to L size. And the other thing is that this check is necessary for every single chunk except the last one. That's why I said if the chunk is not the last one is chunks minus 1. That was the last one in the loop control. So if this is actually true, then I know you have a mismatch. That's why I print out this error message, okay, and then exit immediately. But remember, I still want to do my work, right? I haven't moved this chunk yet. So after that, I do a rewind. I call rewind, then remember fseek, I move my pointer from the beginning of the file all the way to the end of the file. So now when I do rewind, it basically bring the pointer all the way back to the first byte of the file. So this is a piece of code, how I actually use 3 Unix system call for me to manage the pointer of the file. And then I will be able to check whether the file size match the chunk size. There should be other ways to do the same thing, but this is the way I implement. I'm just using the 3 nice function call. It's fairly typical.
Hi, Professor.
Joshua, does that help you to address your issue?
Sorry, Professor, but what is the I doesn't equal chunks minus 1 mean? You just covered it, but
okay. So if I'm actually going to break the file, because each of the chunk size is say 1024, assuming my chunk size is 1024, then you chop your original file and 1024, but the last chunk, because if you think about that, your file is not multiple of 1024. It must be some residual bytes at the last chunk. So the last chunk, you cannot expect to be the same size. Yeah, that's why I want to make sure that you perform this check for every single chunk except the last chunk. Does that make sense?
Yeah, I think I get that.
Okay, great. Okay, anybody else have any question regarding? Yeah, go ahead.
I pretty much have like the code that you wrote down because I was Googling how to check like byte sizes yesterday night. But I kind of like ran into like a predicament. I'm not sure if it's a predicament, but like say you put like when you do breaks your chunks into like 6 files, right? But when you do myheal, you put like say 8 chunks. That means like when it gets towards the end, it'll throw a mismatch for the last file saying that it's inadequate. But shouldn't they like, how do you catch the error saying that the files are missing rather than it's like inadequate?
Oh, the chunk is missing. Okay, that's the other part, right? Missing chunk. So I'm not sure that this two check for every single possibility, but what I'm looking for this homework assignment is asking you to check. Let me actually go back to my break.c, okay?
Yeah. Because the way I have it right now, to check like the missing assignment, it just checks within like say from 0 wherever to the parameter is.
Right. So for example, this is the way we did, let me just do this. You see that this is the way we actually do my my break, right? And I generate each of the chunk, and the file name is basically here, right?
Yeah.
And over here is the index by I. So I start with 0, 1, all the way to the total number of chunks. So right now, for homework assignment number 1, the only thing you need to check is that you do have, assuming you have 11 chunks, then you do have that chunks from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You do have all this 11 chunks. Because if you're missing any one of those, when you do the myheal equivalent of this code, when you do sprintf, say you miss chunk 07, when you actually print the name, when you do fopen on that name, but but here, remember, if you do heal, this one is going to be readable, right? Let me actually just say the heal should look like this. TF is equal to F open, F name, read. Okay, my heal should looks like, at this point, should looks like this. And this moment, if you say TF is equal to null, instead of say cannot open, I would say there is a piece missing. Do you understand what I'm saying? If you cannot open in the my break, that means your file system doesn't give you the right permission to create a writable file. But over here, if you, okay, let me just talk in general. When you do fopen, there's two possibilities you could get failed. Number one, if you try to open a file that's readable only, if you open it, it failed, that means that file doesn't exist. If you do fopen in the write mode and that file doesn't, and fopen fail, that means you're actually running the program in a directory that you don't have a write permission. So that's why in this case, that for the my break here, that means you're missing your write permission. You know, usually no write permission. But if it's a read, then it's basically that file doesn't exist, means that you have a piece. You have one particular chunk that's missing. Does that answer your question?
Yeah, pretty much.
Okay.
All right, cool. Thank you so much.
You're welcome. And anybody else have any question regarding this part about checking the arrow? That's probably the most different. I mean, other than that, if you don't worry about this missing chunk as well as the chunk size, the code should be really similar to my break. But you need to find the right appropriate place to add this, insert this to check, okay?
All right, cool.
All right, good. Anybody else have any question regarding anything?
Professor, just the question I have is not related to what you've been explaining, but it's about basically the chunk size. If I have like a string that is, 1 kilobyte or something like that, is it fine, to load that much, information into memory? Or do we have to do it like you did, where you only do like 8 bytes and 8 bytes step by step?
I think that 1024, chunk size 1024 is fine. It's fine. I mean, 8 byte is really, really memory conservative. And I might actually waste a lot of time for doing system call. I mean, later you will see that when you do system call, it's a concept called software trap, because system call is different from library function call. So system call, you need to do more check to go into the operating system kernel. So therefore, by using a very small size, like 8 byte per call, I'm actually sacrifice a lot of performance. But I think today, if I'm going to write a program, if I know I'm going to running on a 64-bit computer, I will be using 1024. Okay,
right,
yeah, go ahead.
So we can go beyond 2024 then? Is that like a limit to what we can do? Because I mean, so far my program has been like reading the whole chunk into memory and then writing it into the heal file.
Okay, how big is your chunk that you have tested?
So per chunk, I've been doing like 8 kilobytes.
Okay, 8 kilobytes. 8 kilobytes is still small, but okay. I would say today, if you can do per chunk, you can try per chunk 64 megabyte. Okay. That should still work. 64 megabyte, because today modern computer, we typically have 16 gigabyte of memory or 8 gigabyte of memory. So 64 megabyte is no problem. I mean, the reason I mentioned 64 megabyte, I just want to, I don't know if this is appropriate to ask this question here. Anybody heard about a program called BitTorrent?
No.
Anybody? You guys are too young. Okay, BitTorrent is what we call the pirate bay. It's a called peer-to-peer protocol that people share, and 95% of the content that's shared by BitTorrent is illegal. It's illegal. I mean, it's
BitTorrent. Yeah,
BitTorrent.
I've heard of it. Yeah, I've used it.
Yeah. So BitTorrent, each chunk is 64 megabytes. So, but essentially what BitTorrent is doing is that they break the huge file, because at that time, a DVD image is about 4 gigabyte. They break 4 gigabyte into each chunk is about 64 megabyte. And then they basically distribute the movie by distribute the chunks in different channel, and then you will be able to get it. So if you study this homework is really a mini BitTorrent that we try you to do. Okay, and you just need to MyHero to add those things together. The other thing which you might learn from later course in like a Google file system, or the other one we call that Hadoop file system. They're both 64 megabyte chunk. They basically distribute a large file in the internet. So today we're thinking a big file must be stored in one server, right? If you have a file with 2 terabyte, you're expecting the 2 terabyte file is actually on one single server. No, it's not. Google is distribute that 2 terabyte or 4 terabyte file into 64 megabyte chunk around the world. So when you receive some information, say YouTube, you're getting this chunk from server A, you get it, the second chunk from server B. And your player is actually getting there. So this concept of breaking is actually happen universally this day. Yeah. Okay.
Professor, one more question.
Sure.
So you already said that we're able to use your code, but I was wondering if we were able to modify a certain line.
You can. Yeah. Of course, you can use anywhere you want. Yeah.
Okay.
You can modify. You can do whatever. But the important thing, make sure your my break will work with your MyHero.
Okay. Sure.
Okay.
Thank you.
You're welcome.
And sorry, but if we would like you to look at our code, like just to ask anything about the code, do we have to like schedule an appointment with you, or?
There are multiple ways of doing this. One is, of course, we can schedule appointment. I can take a look at your code. If you feel comfortable, you can share your screen over here for segment of code, not the whole thing. This was interesting. I had this mistake I made, is that I have the code and I just flip through it using more, and there are students who actually captured the YouTube video and then watch this very slowly. He captured all the code visually. So I don't want that to happen this time. But the other way you can do is that you can take a screenshot and then send segment to me using Facebook Messenger or something. And also in the later, just for you, Gian, but for the rest of the class, it was very common, happened last year when I debugging a more complicated program like a homework 6 or homework 7. I typically ask the student to send me the whole tar file, because it's debugging. I have to see the whole tar file, the whole make file, in order to run my own debugger to see exactly what kind of difficulty or what kind of situation they're in. So there are multiple ways to do that. I'm happy to help me and the TA as well. Okay.
Thank you, Professor.
You're welcome. Okay. Any other question from the class regarding this part of homework or other part of homework? Or anything in the, let me go to the chat.
I actually have a question.
Yeah, go ahead, Frank.
Yeah, so can you like talk more about the CR and fread? I kind of don't understand how it works.
You're talking about fread, right?
Yeah, and CR.
Oh, CR. Okay.
Yeah.
Okay.
Like I'm confused.
I understand. Let me bring my
Like, is it recursive? Like if you once you read like eight kilobytes
let me tell you what CR is. Okay.
Yeah.
So f reads. So what happened is that let me actually bring up my PowerPoint. Let me bring up my PowerPoint. Okay, so this is my file. Okay, this is my file, assuming that I kind of separate using the line, represent each of them is one 8 byte or 1024, depending on how big the size you want to have. And what happened is that at the beginning, I'm going to use this things to represent. Okay, at the beginning, when you open the file, there is a pointer. That's your, what we call the rewrite head of this file handle. So when you open the file, it's actually giving you the arrow at the beginning of the file. And when I remember earlier, I do my seek, fseek to the seek end, it's actually just move the file all the way to the end, okay? So at the beginning, that this is over here. Okay, now I'm going to copy my code over here. So I'm actually going to explain what is happening in this line. So I'm actually going to try to do this line, what was happened graphically. Okay, and so this is before. Before we do that, the pointer is here. Let me actually move this a little bit. And then I have another buffer. This is called CCC. Sorry, I'm going to use a different color. I'm going to put all of them into a different color. So I will be able to show the difference. Yeah, that should be good enough. Okay, so this is before the call. That the pointer is here, and then I have the memory, and the buffer is CCC. This one is CCC. I'm going to just write it. Wait a minute, no. So this one's a CCC. Oh, I cannot hear. I cannot see the. Okay, so this buffer is CCC. This is the file string F here. Okay, so after the read, after you call this function call, this is going to happen. Number one, after you call that, the pointer, after you finish reading 8, the pointer is actually being placed over here. And also, the CCC now, because you copy the value, is actually going to have the same value as the first 8 byte. Okay, so now the value go in. But the interesting thing is about CR. Now CR represent the number of bytes that you just read in from that F read. So CR is represent the the number of bytes that just being read. So in this case, if it's the first 7 chunks, I actually want to make this chunk a little bit different because the last chunk is usually not 100%, right? The last chunk is usually a lot smaller. So the last chunk I'm actually going to use a different color. Okay, so for the first 6 chunk, the CR should be 8 because every time you read 8. But the last chunk, the CR probably going to be 3 because you only have 3 bytes over there. So CR represent how many bytes you just read. So that's the semantics of fread. Is that answer your question?
Yeah. So if I want to represent, if I read like all of the file and it reaches the end of the file, how do I represent by CR or by something else?
If you want to read the whole file,
yeah,
what you can do is this. Remember we did the L size, right? You can do fread L size. Remember I used the L size to figure out the size of the whole byte. I will read that and I will do like this, and CR at the end of the call, the CR after the call, the value of CR should be equal to L size. Does that make sense?
So the third parameter L size or 8, does it represent like how many bytes it reads once?
Yes. How many bytes I like to read? Yes. That's the size that you're going to read from the F string, the F.
So if I read like 8 bytes every time, and so the first time I do CR and it reads 8 bytes, and the second time, like, does it recurse itself?
Well, every time you see that the first time you call, the pointer is here, so you're reading this 8 byte, right? But after the call, the pointer got moved to this place, right? So, yeah, so therefore,
if I want to continue reading, do I need to like call CR again?
No, you don't call CR. You call fread.
I call fread again. Right?
Yes, you call fread again. So that's why fread is being in the my break is inside the loop. Inside the loop. So it was actually get iterate through the process a few times.
So does it mean like when CR equals like reaches the end of the file?
If a CR is actually 0 or less than 8, then you're reaching the end of the file.
0 or less than 8.
Less than 8, yeah. Any number that's less than 8, you're at the end of the file.
Like, why?
Well, because it doesn't have 8 byte for you to read, right? If it's a less than 8, say, in this case, you see that you read only 3 bytes. So CR will be 3, which is less than 8. So that means if you actually read less than 8 byte, it must be in this block, right? The before the last block, everything is a full 8 byte. So when you read, you should get all of them.
Okay.
Okay?
Yeah.
All right. So any last minute question? Because I have a faculty meeting I need to go through at 3:10. So I'm going to finish my office hour here. I will upload the video. I just wonder, anybody have a last minute short question I can answer?
I have a question, but I don't want to cut in line.
Go ahead, please.
Okay. So I tried to run a command for homework 1 part 1 on my terminal, but it says there's no such file.
Oh, I think what happened to is that the executable file probably is not being set up correctly, because the homework one, the only file that's not there is because you're executing like ecs36b homework one client, right? We're going to do that program, and let me see if I have it here. Yeah, I have it here. So you're talking about part one, right?
Yeah.
So part one is actually this line, right? This is the line we're talking about, right?
The tar the tar command. Are you
the
talking
tar command when you try to do that.
Yeah.
Oh, then you want to make sure when you type the tar command, this file is there. Do you have this file there?
From the Word document, I downloaded the first link, and then I tried to run the tar command.
But you downloaded, did you put it in the same directory when you run the tar command?
I used cd to change the directory first, and then before I used the tar command.
Okay, when you do the tar command, can you do, let me share my screen very quickly. I just want to make sure you do things correctly. When you do the tar command, do a ls. Do a ls to make sure that that file is actually indeed in that directory. Okay, so for example, we're talking about this. Let me just show you an example. So you can see that this file is here, right? This file is here. So when I say tar z xvf ecs36, it won't give me any complaint, right? But if I remove this file, I remove it and do a ls, sorry. If I do ls, the file says no such file. If you run this one, it will say tar error opening archive, failed to open this file. So before you do tar, do ls -l to see if that file is actually in the same directory. If it's in the same directory, is this the error message you got? Is this the error message you got?
Can I share my screen?
Sure, but very quick because I'm already a few minutes late. Okay, very quick. Go ahead.
Oh, you have to enable share screen.
Okay, hold on 1 second. Okay, go ahead.
So can you see the terminal?
Yeah, I can see a terminal. The file is not there. You see that? It said no such file.
And I don't understand why.
Oh, you know, everything you did is backslash. Don't do backslash. You see that you haven't, no, where is your file? Do a ls, can you do a ls? Can you just do a ls? Okay, can you do a pwd? Do a pwd. Okay, apparently it's not there. The file is not there. You're using WSL, right?
I'm using Ubuntu.
Using Ubuntu, but apparently the file is not here. It's not.
Is this the location of the file?
This looks like it's a window convention. This is not the Unix. Are you use virtual machine? Okay, so okay, you're using virtual machine on top of window environment. So now this file is inside your window file system. It's not under your Unix. So you cannot see that. Okay, can I go back to your Unix window? Go back to Unix, type a df. Yeah, enter. So, okay, so you see that you have a window, your C drive is under /mnt/c. So do a ls/mnt/c. No space, you have to put a space between after ls, yes. Okay, enter. Okay, now do download, do ls/mnt/c/D downloads. No, capital D, no. DOWN S, hit enter. Okay, it's not there actually. Where is your file? You know, what happened is that your drive, can I go back to your window? I want to see that where you put that download file. You put it in capital C. Oh, user. Okay.
Right.
Can you go back to the Linux window? Do you have a user? Oh, you have a user. So do a ls/mnt/c capital user /capital users / right. I think JAM52. Do a control P. You don't have to type this every time. /JMA52. Enter. And now you can do downloads. Can you just do a control P? Control P together. Okay, yeah. /capital D. Capital D, and then just type tab. Nothing.
Tab?
D. Yeah, tab key. Okay. Do a
Okay.
O. And then tab key again. Probably you need to do DOW. Do a DOW tab. Now you have ls. Okay, enter. Okay, now you have that file, right? So you do a, can you do a CP copy of all this path /mnt/c user JMI whatever /download and then / whatever the name ecs36. Yeah. homework1part1.tar.gz. homework1part1. You can tab. You can, yeah, that's fine. It's too late. Just then space. No, don't enter. Space.
Okay.
Dot. Put a period. Put a dot. Enter. Now you type enter. Okay, do a ls. Now you see the file is here. Now you can run the tar command. You can just tab it. You can tap, it will show up. Yeah, it's very convenient. Yeah, tap will, okay, now you can get it, right?
Okay, thank you.
Okay, you're welcome. So now you know the problem is that when you're using this kind of dual operating system, sometimes the file location somewhat is different. So df, it will tell you where how to access to the other side, okay?
So do I still have to change? Is there a way to change it into just one system?
No, it's fine. It's fine to have the way you configure. I mean, it's fine to use Windows and Linux. You learn more. I mean, in real world, we always use multiple operating systems. So this is for education purpose. I think this is great for you to learn this. Okay?
Thank you.
Okay, you're welcome. All right, I have to go, and thank you very much, and I will see everybody tomorrow. Okay? Okay, bye.
Bye.